Hello, this is Mike Lawless, and in this video, I'm going to discuss examining data and looking at graphs in ADMET Predictor. You see here that I've read in the demo2d.smiles file from our user app data directory, and you'll see that there are several columns of user data that were read in with the smiles file. The first thing I'm going to do is simply calculate ADMET properties. So I click on this Add Me icon and then calculate the data. Now, once I've calculated this, I can use these tabs at the bottom of the GUI. Will display all the properties in the spreadsheet. User inputs will only display those associated with the information that was read in. Now, later, if I create an equation, it would also show up here or add other attributes in here. Then we have tabs for each one of the modules in ADMET Predictor. So we have the physical, chemical, transporters, metabolism, toxicity. And you'll notice that each one of these create what we call star plots. And I'll come back to these in a minute. Then we have the simulation tab, which if you click here, it's going to prompt you, tell you that you haven't calculated these properties and ask you if you want to calculate them now. And I'm just going to skip that. The descriptors are under the descriptors tab, and there's over 300 descriptors that are used to build the models. Then if you have any user models defined, which I have a few here, they would be under the user models. Risks, these will be the ADMET risks, including the ADMET risk, absorption risk, SIP risk, mute risk, etc., along with the rule of 5. And then I have a couple custom tabs, which I'll discuss later on in this video and show you how you can customize these tabs. Okay, so now let's discuss kind of rearranging columns within ADMET Predictor. First thing I'm going to do is make a little bit more room for the spreadsheet itself. So I'm going to take the spreadsheet controls and hide them. Also, I'm going to hide the graphs over to the right so that we'll have more area for the columns themselves and the data. So let's say I just want to take the S plus SW column, which is our aqueous water solubility model. I can just grab onto the header and then move it over here to the first column next to the identifier. Okay, so now that I've moved this next to the identifier, it will stay there as long as I'm in the PhysChem tab. If I switch to the user inputs and then back to the PhysChem, the column will be displayed in its original position. You'll notice that there's a dark black vertical line here. That is called the pin line. Anything left of that will always show up in that same position no matter what tab you're in. So if I want the aqueous water solubility column to always be displayed no matter what tab I'm in, I can go over and I can pin it. So here I'm just going to go over and right click on the column header and then select pin column. That will move it over to the left of the bold line. Now, no matter what tab I'm in, that column will always be displayed in that same position. Now, also, you'll notice that there's a little bit more information here in the S plus SW column, and that's the uncertainty estimates for this. We also added a new feature recently where under the View tab, you can go into Resize Columns and fit all cell data. Now, when I do that, it increases the size of the column so that everything in it will be displayed no matter where I am in. We can also rearrange columns under the using the Arrange Columns dialog box. So that's under the View columns. I also use Control-Alt-V to bring up this dialog box. Now here we can take any of the displayed columns and rearrange them. So let's say we want log P and log D up near the top next to S plus SW. We could also add other columns from other modules or descriptors over into the displayed columns and then rearrange them here. So I'm just going to use the S plus log P and S plus log D columns. And when I click there, you'll see that they're moved over. Now, you will also notice that they are to the right of the pin line. If I want those columns pinned, I can right click here and set the pin line here. Now I can switch tabs and I'll always have those columns. Now, if you want all your, if you want certain columns to be in a certain place, you can create a custom tab. So that's obtained by clicking on the customize tab down here at the bottom. And I've already got a couple defined. I'm going to add a new button. Let's call it my props 2 or click OK. And then you can select various properties over here. Now, these will be selected here, and then I add them over to the selected attributes here. Now, my props 2 will have these 4 attributes in it. We click OK. As you can see, it's added a new tab here, and we can click on that and see those columns there. And of course, the pin columns are also going to show up. Okay, so now let's go over to the PhysChem properties tab here. And let's say we want to filter for various properties here. So there are some advanced widgets over under the spreadsheet controls. Again, I'll pin this column so that I can, or pin this widget so I can work with them. The first thing you see here is molecular, so they're all listed at molecular properties. So let's say we want to filter for molecular weight, let's say. So we would specify the MWT column here, and then it gives you the range of the whole data set here. So 32 to 478. Let's say we want to filter out anything below molecular weight 100. So I just type that in here and then hit the tab. This advances this pointer. And then over in the right-hand corner, you can see it says 96 unhidden rows, 8 hidden. And the 8 hidden ones are the ones where the molecular weight is below 100. Let's say we want to look for S plus log P, and we want to filter out anything below, let's say, 1 and up to 5, let's say. Now, once I enter this, I have to either click in another box or hit the tab button to update the filter. And then now we've got 75 rows hidden, or excuse me, 29 rows hidden, 75 displayed, and they would meet this criteria. Molecular weight between 100 and 478.2, log P between 1 and 5. And then if I want to just go back to the original one, I can just click this on mole property, and also this one, go back up to mole property, and you'll see that all of the rows will be displayed. We have a couple tools to search for various rows that meet certain criteria. So the first one is under the edit menu, and it's find text. I also use the Control F shortcut key to bring up this dialog box. And here we're going to use no for the search query, and we're going to search for 2C9 compounds that are not a substrate. So we're looking at our substrate model. We're going to allow a partial match search. So, these all have confidence estimates in them. So if we click OK, that finds 49 rows that meet that criteria. In other words, they have a no for the 2C9 substrate, and we can find that over here. So here's your 2C9 substrate, and you'll see that they're all no. We can also move these rows to the top. So we can move to top, and then you'll see all the ones up here that are no, then everything else is yes. We can also go back into this dialog box, and we can turn on do not deselect items. So now we can change the query, and let's look for compounds that are not a 2C19 substrate, and then click OK, and this will add another 20 or so rows to make the total 60. So these are compounds that are neither a 2C9 or a 2C19 substrate. Another tool we can use is the Query Wizard. That's under Edit Query by Structure/Property, or again, Control Q. So this is where you could type in a query. I'm going to demonstrate using the Query Wizard. So with the query wizard, we would specify certain criteria, and we can specify more than one criteria. So let's look for compounds that have a low log P. So we're going to look for S plus S log P. And when we double click it, it transfers it to this query tool here. And then let's look for compounds that have a log P greater than 2. Click OK. So it's building this. And we'll look for compounds also that have a PEF value less than, let's say, 2 also. So we click that in there. So it's building the query here, and then when we say OK, it transfers it over into this query box here. We can also change this criteria once it's in this dialog box. So in the query dialog box, you can't change it here, but you can in this dialog box. So if we click OK here, just finds 5 compounds that would meet that criteria. If we want to expand that, we could go back into the query tool here, and let's say compounds with a PEF of under 3, click OK, and it found 7 more compounds, so a total of 12 now. Okay, so now let's move on and discuss heat maps. So heat maps are created by this icon here. So it's the heat map icon. I'm going to click on that, and then we can select various columns to color the cells in that value. So we can color by red, yellow, or green, or blue, white, red. So the default is red, yellow, green. So low values are red, medium values are yellow, and high values are green. And it's a continuous spectrum there. Now, if we want to do, this will only work on what columns are displayed. So I'm in the metabolism tab. Let's go to the all tab, click on the heat map icon, check all. So we're going to select every column here and then just click OK. And you'll see that it's highlighted those columns. So let's look at the molecular weight here, or the formula weight column. If we click once, this will sort the column in ascending order. So the low value, 32, is red, and then if we scroll down to the very last one, the highest value is green. Now, if we want to reverse that, say we want low values green and high values red, we could right click on this column header and then set the color direction to descending. Now your low values are going to be green and your high values are going to be red. Note that this will also color text column types. For instance, CYP1A2 inhibition, the no's here are colored red and the yes are colored green. You could reverse that also. Now, if all of the values for a specific column the same, then it won't do any coloring. So let's say we find all the no's for 1A2 inhibition. So let's click here and go to the 1A2 inhibition. Okay, and that selects those. Now let's say we want to hide those. So under the View menu, we'll go Hide, Unhide, Hide Selected. Now you see that this column is white because all of the values in that column are the same. Now you noticed after I calculated properties, these star plots showed up. So I'll briefly go through what these star plots are. There's a file in the user app data directory that defines what star plots will be created and what the properties of those star plots will be. So it's a customizable file that you can turn off various star plots. So let's look briefly at the CYP substrate. So if I hover my mouse within that wedge there, it will tell me what that wedge pertains to. So this is CYP2C9 substrate, 2C19. This yellow value, which is much smaller, is 2D6. And it's simply the length. For this is a binary model. It's either yes or no. So no is a very short wedge, and yes is a wedge that's full length there. We can right click on this and we could modify this plot if we wanted. Now, we would just modify it for this session. but we could, color a specific one, change the color of these, and do various attributes here. If we look over at the SIP clearance value, you see that the SIP rat liver microsomal clearance is in log units. So let's take a look at how that's defined. So the rat liver clearance here, it's a fixed value, minimum and maximum 3.5, and it's defined on the log scale. And the reason we do that is to just allow this to go across various spreadsheets. So it's an absolute scale from 0 to 3.5. If we go over to the PhysChem tab and we look at something like uh, molecular weight, this is relative to this particular spreadsheet. So the lowest molecular weight is 236, or excuse me, 71, and the highest is 45, as seen there in the brackets. And this one is 236, and what determines the length of the wedge. So if we change something to say, let's log p, this is kind of an intermediate value. But if we sort and we find the smallest log p, you'll see that that is a very short wedge. If we filter the other way so that the highest log p value is up here, you'll see that this is the longest wedge there. We can right click on a particular attribute and say insert column and insert a star plot, and then we can specify what we want to plot on that. So let's plot absorption risk, and then let's have that as red, and then click OK. So that will add the absorption risk. Let's look at for compounds that have maybe an aliphatic amino acid. I believe that's what that descriptor is. Again, we can click on that. Let's change the color of this one to be dark blue. And then we just click OK, and then click OK, and we get these two wedges here where this is the length of that particular wedge. So you can create your own star plots. Maybe if you have particular attribute types that you read in from your corporate database, you could define star plot for that, and then it would look at your own values. So now let's switch gears and talk about the various charts we have. I've hidden these, so I'm going to go over here and hover on the chart 1 and then pin that. This is a certain size when it's pinned over here, but we can undock this simply by left clicking on the yellow area here and just bringing it over to the center of the screen. And then let's resize this particular dialog box here. So this is by default under the settings dialog box. I think if we go to display, these are the charts that are displayed on startup. So a histogram and a 2D scatter plot. So those are by default displayed. And of course, you could change those values here. So with the histogram chart, it's going to chart from a certain range of that particular formula weight here for this example. Now, if we want to change the attribute, we click on the XYZ icon here, and then we can plot any one of these distributions, a distribution for any of these properties here shown in this dialog box here. We can also clean up or specify the number of bins here. So let's leave that at 10, and let's go from 50 to say 500. So we can specify a minimum value and a maximum value. And then if we hit the apply button, that will just apply that criteria, and we can do other modifications while keeping this dialog box up here. So let's do 0 for the x-axis, number of decimal points. We can display up to 32 bins per page, and those have options of using the same scale or ordering the labels by bin count. We can also use the Y as a color mode, so we'll keep that, and then let's click OK, and that kind of cleans up the count. Now let's say we select a few of these columns here. I just selected them manually. We could use a query to select those. And then once we can toggle in two color modes. So here the red bars would be for the 5 compounds I have selected, or 5 rows I have selected here. And this will correspond to this axis over on the right here. So this is more of, it basically is kind of puts these on a percent. So the highest value for red would be the same height as the highest for the unselected values here. If we want to just make them all on the same footing, we would go back into the settings and say, don't use this second axis. And then here now we see that this highest count of 2 relative to the highest count of 5 in here. We can also look for out of scope measurements. Of course, for a molecular weight, there wouldn't be. And then these widgets allow you to kind of loop through the various columns in your spreadsheet. So it's going through the user defined attributes. Now, melting points, this is the identifier, the smile string. I'm not sure if that makes a lot of sense, but ADMET risk, ADMET code. So this lets you look at the various compounds with various codes, ADMET codes in here. You can display those. You can go to the very last or to the very first here. There are other options here to change, if we click in here, to change the background color, the font size, border type, etc. And then finally, we can export this dialog box. So the default is just to save it in the clipboard. This will allow you to then paste it into another program. We could export it into a file. That would export actually the values within the spreadsheet. If we change to text data, we would export the values for the X and Y axes here. Now, if we want to dock this back in, we again left click on the column title. Now the default is kind of to go over on the right hand side, so that'll get us back to where we started here, and then we could unpin that so it would hide that. Now let's take a look at chart 2. Again, I'll hover over it, and then let's undock it, and again resize it for what we want. I'm going to show all the rows. I'm going to go view, hide, unhide, and then unhide all so that everything is displayed in here. Here we're plotting the experimental log P versus the molecular weight here. Again, we can change that to specify our X and Y axis. We can also specify a color or we can color code the points in here. So let's look for aliphatic carboxylic acids and then highlight that. You see most of them are red points, but the green points here will have a carboxylic acid in them. And as you just saw, I can take my mouse and hover over a particular point, and it will show the molecule associated with that point, the name of the molecule, and then the two properties that are plotted along with the color properties. So this doesn't have a carboxylic acid in there. This button here will display those, so we can change that. We can also highlight selected points here. So we've got 5 points or 5 rows selected in the spreadsheet. Clicking this will highlight the corresponding 5 points in the spreadsheet. Similarly, we can select points in the spreadsheet, highlight them, or excuse me, in the graph, and then push this button and it'll highlight the corresponding rows in the spreadsheet here. This will throw away out of scope predictions. Now, since we're plotting user data, nothing's out of scope. We can also just show the selected ones, and that kind of lets you zoom in on a certain area of the plot. We can also expand that. So if we click on the zoom and then select a particular area, it zooms on that portion of the plot and kind of makes that full size there. And then this button will unzoom it. Now let's go ahead and show everything here. This button will create a linear fit. So this, I'm using version 10.2, and right now it just displays the best fit line here and gives you statistics up in the upper part of the graph. So the R squared is 0.416. So there's not a lot. There's a little correlation between experimental log p and the molecular weight. The linear regression fit has an RMSE and an MAE. The best fit line has a slope, uh, kind of not close to 1 here, and an intercept at minus 1.4. There's 104 points showing. And then these two RMSE and MAEs are kind of based on the actual values from the two axes, whereas this is the RMSE for the best fit regression line there. And then again, we can use this widget to go to the next value. So here it's changing the x-axis you see here. So this value down here keeps changing. If I hold the control button down, then the y-axis changes. So you can kind of loop through the various column types and plot them on this plot here. So another way to put this graph up instead of using the controlling it and placing it in a certain position is to go into the view dock charts into main window. And I use this a lot if I've kind of lost the graphs. If you can close these or you're not sure where they're showing on the screen, you can go into view dock charts in main window. And then let's just talk briefly about some of the other charts we have. So if we go under data, add new chart, we can create a 3D chart here. So again, we would click OK. And this appears along with the 2D. So here to undock this, I could just grab on left click on chart 3 and drag it over, and it would show these values here again. And then we could again plot this. So molecular weight, instead of log p, let's go under our predicted S plus log p, and then say maybe for the third axis, plot the aqueous water solubility here. And let's use that as a log value here, and then click OK. And so this plot you can turn by using your right mouse button will turn in this direction, also along the kind of the x-axis here. The left mouse button will kind of move this around in there, and then the wheel will zoom in on various plots here. And you can also, again, hover over or click on a button on a point, and it'll bring up the image of the structure and then the values for exactly what you're plotting there. So if I double click, that will put it back up. Then we have other chart types. A bar plot is similar to a histogram, except the bar is on the y-axis. And then you also have a confusion matrix. So we would use this maybe if we're building a binary classification model and we want to create a predicted versus actual confusion matrix for that. And that'll also show the statistics for everything. Now, in order for the confusion matrix to work, both of the columns that you select have to have similar attributes. So they both need to say no, for example, as a class, so you can't have 0 for one column and no for the other column. That won't work there. So it does, if you have trouble with those graphs, that may be the problem. This concludes the video on data and graphing in ADMET Predictor. I want to thank you for watching. My name is Mike Lawless, and my email address is mlawless@simulations-plus.com. If you have any questions, just please send me an email. Thank you. Bye for now.